Hi, the objective of this fourth video on synthetic division is to frame the roots of a polynomial. First, we have checked whether all the roots of a polynomial are greater than a real number a. Now, in this video, we'll verify if all the roots of a polynomial are smaller than a real number b. I'll be using the C language for this tutorial. A link in the description will take you directly to the work page. This is the work page, a wikibook. You must first download the hash files. You can find here the hash file. You can then download the first example, a C file. Synthetic division. The long division of polynomials can involve many steps and be quite cumbersome. Synthetic division is a shortcut that can be used when the divisor is a binomial in the form x minus k, where k is real number. In synthetic division, only the coefficients of the polynomial are used in the division process. Can you explain how to verify if all roots of a polynomial are smaller than a real number b using synthetic division and the C language? Yes, if all roots are smaller than b, then using synthetic division with the binomial x minus b, all the coefficients in the first row must be positive. Using the synthetic division with the binomial x minus b, all the coefficients in the first row must be positive. Now, I try to download the first example. This is the first example. I copy this example into my editor. I must verify if I have all the hash file. Yes, I have all the hash file. I save the C file. This is a polynomial. This is a polynomial that I want to study. Alors, the degree of this polynomial is 4. You can find here the coefficient of the polynomial. It is array. For b, for the first part, I have chosen for b the value 3. In second part, I have chosen for b the value 5. Now I want to draw the polynomial into Gnuplot. I call Gnuplot. I try an example. There is no other axis, so I close the window. And now I have the axis. You can see here the first row, the first root, a second root, a third root, and the fourth root. In first, I have chosen for b 3. 3 is here, so I can see there is a root here which is not on the left of B, so B is not an upper bound for the 0 of P of X, is not an upper bound. In a second step, I have chosen for B the value 5. 5 is here. Now I can see that all the roots of the polynomial are on the left of B. So 5 is the upper bound for the root of P of X. Now I try the C file. This is the polynomial. This is the binomial. I have chosen here 3. 3 is here. If I divide P of X by X minus 3, the first row have some negative number. The first row have some negative number, 1, 2, 3. So minus 3 is not an upper bound for the 0 of P of X. So plus 3 is not an upper bound for the 0 for the roots of P of X. Now for B I have chosen the value 5. 5 is here. The first row are non-negative number. All the coefficients in the first row are positive, plus, 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 plus. So plus 5 is the upper bound for the 0 of P of X. So 5 is the upper bound for the 0 of P of X. I try 15, for example. Now, for the first part, I have chosen for B the value 3. You can see here some sign, the value, a negative value. You can see here some negative value. So 3 is not a upper bound for the root of P of X. Now I have chosen for B the value 50. 50. The first row are non-negative number. All the coefficients in the first row are positive, plus, 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 and plus. So 50 is the upper bound for the 0 of P of X. But 5 is better because it is near the root. Now I want to try the second example. I copy the second example into my editor. This time the degree of the polynomial is 3. You can find here the coefficient of the polynomial. There are in an array. For B, I have chosen for B, the values I have chosen for B is 3 for the first part. In second part, I have chosen for B the value 13. Now I want to draw this new polynomial. Now this is a new polynomial. I have chosen here, I have chosen 3 for b, for the value of b. You see 3 is here, and you can see there is a root on the right of b, so 3 is not upper bound for the root of p of x. In the second part, I have chosen for b 13. 13 is here. You can see on the graph that all the roots are on the left of 13. So 13 is the upper bound for the 0 of p of x, or 13 is the upper bound for the roots of p of x. Now I try the new example. This is the new polynomial. It is the degree of this new polynomial is 3. Is 3. For the first part, I have chosen the value I have chosen for b is 3. The first row have some negative number. For example, here there is a negative number. So 3 is not an upper bound for the 0 of p of x. 3 is not an upper bound for the root of p of x. Now I have chosen 13. 13 is here. The first row are non-negative number. All the coefficients of the first row are all positive. So 13 is the upper bound for the 0 of p of x. So 13 is the upper bound for the root of p of x. I can try, for example, 130. In the first step, I have chosen 3, and I can see there is a negative coefficient. So 3 is not an upper bound for the root of p of x. In the second part, I have chosen for b 130. The third row are non-negative number. All the coefficients in the third row are positive. So 130 is the upper bound for the root of p of x. But 13 is better. 13 is better because it is most near than 30. 113. Okay. If I use 13, all the coefficients in the third row are positive. So 13 is the upper bound for the root of p of x. Can you explain how to verify if all the roots of a polynomial are smaller than a real number b using synthetic division and the C language? Yes, if all roots are smaller than b, then using the synthetic division with the binomial x minus b, all the coefficients in the first row must be positive. Yes, Alors, this is the fourth video. This is the fourth video on synthetic division. Thank you.